Perfect. Well, welcome everyone. So I'm Mary Cameron. I'm here representing the British Occupational Hygiene Society. Thank you so much for joining us for today's webinar. We have the wonderful Chris Steele from the HSE talking to us about hand-arm vibration on Valentine's Day. What could be a more romantic topic? Anything. Literally anything is more romantic than what we're talking about today. But seriously, the hand-arm vibration is a very important subject as thousands of UK workers are suffering from workplace-caused hand-arm vibration syndrome. So this is a crucial time to be talking about this and working together to reduce these numbers. And I can tell that we all agree on this because of the huge turnout for this event. I think we broke a record today. So clearly everybody's very hungry to learn as much as they can on this topic. Before we get stuck in, though, in our audience today, we have a wide range of professionals listening in. I'd like to encourage anyone listening who's perhaps less familiar with who the BOHS are, what we do check us out at bohs.org. The BOHS is home to occupational hygienists and other associated professionals who are involved in workplace health risk management, including hand-arm vibration. So yes, we're very lucky today to have with us Chris Steele, who is a noise and vibration specialist inspector for the HSE. Chris has worked in noise and vibration control for over 20 years, and I had a little bio written for you, Chris, but honestly, I don't even think it's needed because your reputation clearly precedes you or the amount of interest that we've had here. So I'm sure as well we've all seen the recent updates to the HSC's hand-arm vibration web pages, which Chris will be going through, as well as expectations from those providing hand-arm vibration management support, where to find reliable magnitude data, how to estimate trigger times, clarification on handheld adapters, and more. Chris has a full agenda here today. So I won't take up any more of your guys' time, and I'm going to hand straight over to Chris from here. Please do drop your questions in the chat box. I'll be keeping track of them as we go along, and we'll have Q&A at the end. So over to you, Chris.
Thanks very much. You can hear me okay? Just checking that.
Perfect, perfect.
I'm going to talk to you today about the web page updates, measurement and monitoring practice, and then have reporting third-party advisors, the types of reports and the types of things we expect to see. So we'll start off with the web pages. The main reason for the updates is to improve accessibility, update links and remove any old references. So some of that work's still ongoing. You might find that it's kind of difficult to access some pages because we're still in the process of changing stuff. But fundamentally, our overall advice for hand-arm vibration hasn't really changed. We've really just updated things to try and make it easier to read, easier to understand and easier to access. So what have we done? Well, the first thing that you might have noticed is that the halves calculator has been updated. That's the web address that you can find it at. All we've really done here is make it so that if you now download it onto a mobile phone, that it can be used on a phone because the macros were messing that up. So if you're using an older calculator, that's fine. The thing will still work and the calculations you'll get from it will still be useful. But the new calculator should be something that you can use on your phone now. We've also removed a PDF version of the vibration data table that used to be up there. That PDF was just a regurgitation of what was in L140. That's gone. You can still find that table in L140, but if you go to this web address, this is where you'll find the vibration data. What I would say is that any updates or any additional tools that we add to that table will most likely appear here first than anywhere else because this is the simplest thing for us to update. But we've got the range there and we've got the initial recommended values. Another big change to the vibration page is that we've now got guidance on measurement and monitoring. So in the past, we had a PDF document that was an FAQ on vibration measurement and monitoring. Fundamentally, what we're saying hasn't changed in any significant way. But it's now in a web page for accessibility reasons, and also it's actually written specifically with the duty holder in mind. I think the previous one was sort of trying to be speaking to multiple people at the same time and not doing a good job of that. So that's the web updates. The measurement and monitoring practice that we're looking at, what our expectations are, is essentially what is in that page. But let's just pause for a second and just remind ourselves what HSE's minimum expectation is for duty holders. Our minimum expectation is that the duty holder will figure out what their exposures are based on their understanding of their job and task, feed that information into the calculator or some calculation method, understand whether they're above the action value, and then focus their time and attention on control, information instruction and training, and health surveillance. And for really, really small organisations, we are still accepting of the idea that they would use the rule of thumb. So if they think they're using rotating tools for more than an hour and they're basing that on their typical work activities, if that puts them above the action value, they focus on their control activities. An HSE inspector is going to ask duty holders what they're doing to control risk, no matter how much monitoring or how many measurements they have. We're always going to be asking about control, information, instruction, training, and having measurement and monitoring data isn't in and of itself something that will guarantee that you will not get enforcement taken against you. That is how we see the duty holder spending their time. I know that I've shown this before. I know I said it before in the past, but I'll say it again. My concern is with your duty holder. I don't care whether you spend 1 day a week or 1 day a year on it. If you spend that day thinking about hand-down vibration, your focus should be on the bigger boxes. I know for people who do measurement and monitoring and risk assessment, that is the biggest part of what you're up to. But if you're a BOHS member and you're out doing measurements on site at a factory, you're there for 1 or 2 days. For the rest of the time, the duty holder's activities should be centred around control, IIT and health surveillance. So measurement and monitoring, what are our expectations? They're now in this web page. I make no bones about the fact that I'm just going to read out what it says because, well, it will save you having to do it, but I'll try and add a bit of information as we go through it. Let's start off with the monitoring practice. What are our expectations? Well, monitoring can help you make an initial assessment of exposure or limit exposures to those employees identified as high risk by your occupational health provider. So we do think there's a place for monitoring. Now, you might carry out a period of monitoring exposure times to ensure that workers have not changed or make periodic random sampling of exposures to verify that your control measures are effective, but you should not need to monitor daily vibration exposures. It's not something that the HSE asks for. It's not something that the regulations ask for. If you're using a monitoring system to prevent employees from reaching a set limit, be aware that retrospective recording can result in employees exceeding the set limit before you know they've done so. And we've seen this on site, whether you're using a super duper high-end technical bit of monitoring or just a piece of paper, we have taken companies to court over the fact that they haven't acted on exceeding limit values that they have recorded. And do not confuse electronic monitoring systems with vibration measurement systems. Again, we say that because we have come across health and safety consultants who have bought monitoring systems thinking that they are capable of doing vibration measurements. And in one instance, it was simply a timing device that they believed was capable of doing vibration measurements. So we're starting to talk about measurement. What are our expectations around measurement practice? Again, this is where you'll find it. And again, I make no bones about reading out what it says. You only need to measure vibration magnitude if you cannot get suitable data for your risk assessment from an alternative source. It's not a regulated requirement to do vibration measurements. If you're looking for an initial source of data, we would suggest you go and look at the vibration data we've got on our website. It's not an exhaustive list, and so there will be instances where you might need to get data yourself. If you're doing vibration measurements, and you're going to use, or you're not doing vibration measurements and you're going to use the manufacturer's data, it's good practice to check. Is it the tool in use? Is it doing the job and task under the review? If it's lab-based data that you're using, have you added the key value in? And some lab-based data is more credible than others. My colleague Sue Hewitt has written an entire report on that, which is on our website. The key value is like a uncertainty factor. Does it look credible when you compare it against other similar tools, data sets? And you can compare it against the HSE data where we give a range. If it sits within that range, you can be reasonably comfortable that it's okay. If it's much higher, maybe there's something wrong with it. If it's much lower, check that you're using check that it is a low vibration tool. And we often suggest, or we generally suggest, that you try to find 2 or more data sources if you're using existing data. Appendix 2 of L140 and BS 5349 should be used for guidance on measurement. And instrumentation should meet the specifications for measurement for hand transmitted vibration given in 8041. So that's the accelerometers, the transducers and their accessories, and methods for mounting them should be carefully selected. Well, what do we mean by carefully selected? Because that can be quite difficult to get a handle on. For the first position or the first starting point for us, that is something which is physically clamped or physically attached to the power tube. And there's an expectation of what that would look like given in the standards. But we know that the positioning of that accelerometer can be affected by, can affect the measurements. So if you stick it at one end of the handle, you might get a slightly different level than you would get at another end of the handle. And so there is advice given in the standard again on examples of practical measurement locations for some common power tools, but this doesn't cover everything. And we thought, well, maybe it would be helpful if we showed you a load of photographs of where we have attached the accelerometers to the power tool. So you'll see here that we're generally trying to get it as close to the hand position that the person's working on. That sometimes we can't always achieve that, but we are trying to get to that position. And you'll also see that we're often putting bits of tape onto the equipment, partly to help maintain the location of the accelerometer, but sometimes to stop the cabling from being moved around. We've got loads of photographs like this, and we have talked about whether we should try and put them up on the website somewhere or get them up somewhere so that people can see what we do. And you know, if you're doing what we are doing, we're unlikely to take an issue with it. Right, what if you can't use a rigid mounted system? Because that can occur. So starting point is transducers should be mounted rigidly to the vibration surface, as close to possible where the vibration enters the hand. If fixed mounting systems are not feasible, Appendix D of 5349 gives advice on the use of handheld adapters. Measurement results are unlikely to be representative if you're measuring away from the palm of the hand or use a measurement position that's on the fingers, the back of the hand or the wrist. And we are talking specifically about gathering measurement data that you're going to use to populate your risk assessment. If you're worried that you've got a piece of equipment that isn't measurement in the correct way or isn't set up to do those measurements, then ask the measurement supplier to state in writing that their equipment complies with 8041 and it can be used in compliance with 5349. And the last thing is, if you want to obtain vibration measurements for your own tools, you need to arrange for a competent person to carry out measurements for you using specialised equipment. There's three parts to getting good measurement. One is that you're using the correct equipment. Two is that the equipment is correctly attached to the tool. And the third is that the person who's undertaking the measurements is competent to do so. So that leads us on to our third part that we were going to talk about here, which is third-party advisors and report writing for halves. So over the past few months, we've been working with some vibration consultants to talk about what are the expectations around competent third-party advice. So a good consultant should be able to demonstrate that they're competent to do the work, help duty holders understand how the law applies to them, and provide advice on ways to reduce hand-arm vibration exposure. So let's just go back through that again. The question that you maybe want to ask yourself at this stage is, do you actually need to be able to do vibration measurements in order to be a competent advisor on hand-arm vibration? Well, actually, no, you don't. A lot of the training courses that are out there are on the management of hand-arm vibration. And really, if you're competent to give advice and you can use the calculation sheet that we've got and the data that you can get from manufacturers and the data that's already there, then there's nothing to stop somebody from being a competent advisor if they can demonstrate that they're competent to do the work. They can actually help the duty holder understand how the law applies to them. So do they need health surveillance or information instruction and training, and provide advice on ways to reduce exposure to hand-arm vibration. If you're looking at a report, a good report should have things in it like what the job, the task or the worker's typical exposures are, and are they above the action values. We also expect to see who will need health surveillance, whether it's a particular group of individuals, people that work in a particular space, or named individuals, who will need information instruction and training, and what controls they could adopt, what controls the duty holder could adopt. Generic advice is good, specific controls are better. What do we mean by generic controls? Well, if you go to this web page, you will find our operational guidance, and within our operational guidance, we have a list of industry controls that we expect to see. So in this instance, if you're going out to someone that's making concrete molds and they're using a sand rammer, we would expect them to have considered and ideally be using, but at the very least considered using something like mounting an electric hammer on a frame or mounting a pneumatic rammer on a semi-rigid balancing arm. And if they're not doing that, there would be questions as to why they're not doing that. We would really like to see this type of information that's in our operational guidance being put into reports for advice to duty holders on a standard basis. What about understanding exposure? Because that's something else that we were asked about. Well, regular and frequent for us, usually about at least sort of 3 days a week. We would expect that to be regular and frequent use of power tools. I would include seasonal working as exposure that could be regular and frequent. If someone is cutting grass all summer and then not cutting grass in the winter, we know that those types of people can get hand-arm vibration syndrome, and so we would expect that to be included. But the best way for you to understand what the exposures are is to talk to the duty holder. Talking to the duty holder about what they do, how much it costs, how they monitor work rates is likely to help you understand exposure a hell of a lot better than anything else that you can do. Right, well, what do I mean by that? What about some examples? Well, we know that if you've got people cutting grass and trimming hedges, that if they understand how long it takes to do 1 square metre, you can then pretty quickly estimate how long they're going to be spending on things just by how big the area of grass is or how long the hedge is. And we've got local authorities and councils up and down the country that are doing this type of thing. We see them using takeoffs from maps and drawings in order to estimate exposures. And let's be honest, the size of a typical football pitch doesn't get any bigger. So they know if they've got 30 football pitches to cut, that they've got a fair idea of how much that's going to expose them. We've got metal fabrication companies that are able to tell us from the drawings that they produce what vibration exposures are likely to be. They do this by understanding that for every 500 mil of welding that they do, that is equal to a certain amount of use of a handheld grinder. And so they know that by measuring up all the welds on a component, they can estimate vibration exposures. We've got companies who have gone to the extent of weighing their grinding discs to see how much material is removed from the disc before it gets replaced. And then from that process, they can then understand what someone's exposure is based on how many discs they've used over the course of a typical working day. And we have got at least 2 house builders, timber kit house builders, who understand what their exposures are based on their technical drawings, their building information models and their Revit files. They know exactly how many cuts, how many screws, how many nails, how many drills go into these buildings, and they can tell us that for a 2-bedroom house or a 3-bedroom house, the first fixed joiner will be exposed to a certain amount of vibration, whereas the second fixed joiner would be exposed to a different amount of vibration. And we even have companies that do dry rot and wet rot replacement who can tell us what their vibration exposure is before they even get to site. They do this by when they send out the surveyor measures up and prices a job on how many square meters of walling has to be replaced. And by knowing what type of wall it is, when they do that calculation for the pricing, the Excel sheet that they have for the pricing automatically calculates a vibration exposure for each job. So they can then make decisions on how many people to send to site, which tools to use, and whether they should spread the work over 2 days. Right, so what's next for HSE? So 24-25, this coming work year, HSE inspectors are going to be focusing on hearing protection for the first time in quite a while. We're going to be talking about cuff a lot. We're using that as a handle to get people's understanding of hearing protection up. Cuff is about the condition of the hearing protection, whether it's been used, is it fitting the ear, is it fit, and is it fit for purpose, has it been specified correctly? I'm hoping that there'll be a joint BOHS UK Hearing Conservation Association meeting later on this year where we can talk about that, but I've got some other talks lined up as well, so look out for them. And HSE are also working on web advice on what third-party vibration consultants should be doing. So some of the stuff that I've talked about today will potentially end up on that web page. I will not make any claims as to when that will happen because I've upset quite a lot of people in the past by saying that I'm expecting a web page to go up, and it took a hell of a lot longer than anybody ever expected. Right, so let's just pause again before we finish and just remind ourselves what HSE's minimum expectation is for a duty holder. Rough estimation, or a good credible estimation of what they're up to based on their jobs, their tasks. Understand whether they're above the action value, and if they are, the regulations come into place and they focus on control. And the bigger the box, the more time we expect them to spend on that. What we have talked about today over the past 27 minutes is that little box down there in the corner. Right, I'm going to leave you with some link pages. I'll try and leave that up there for as long as possible, but I'm finished now and I'm happy to take any questions that you have.
Thank you so much, Chris. Oh my gosh, that was a lot of information, but I definitely feel like a lot of that's been clarified for us. So you guys, please do type into the chat box here any questions you have. I have a whole list of questions here, but I don't want to, take over the show too much. So please, somebody else go first. Here we go. Okay, we have one for you, Chris. Right. So, Chris, you mentioned taking duty holders, employers to court. Has HSE ever had occasion to prosecute or otherwise enforce against duty holders, like tool suppliers? So, for example, for providing tools for which it would have been reasonably practicable, not providing vibration data or providing inaccurate information.
So no, I don't think we have, but then that's not necessarily me that does that. We've got a supply division within HSE who chase up on tool suppliers, so that kind of comes under a kind of wider heading of the information that they're given. So it's possible that they have, but it's not necessarily the sort of thing that we would automatically get engaged in. What I would say is we've got a buy quiet expectation. We also have an expectation for to buy vibration efficient as well. If you're coming across tool suppliers that aren't providing vibration data, then the first protocol would be that you ask them for it. If they still say no, then you should have a discussion with their trade association or your trade association. And if you're still getting nowhere with them, then you can pass that information on to HSE and we will chase them up. I have chased up tool manufacturers in the past. I have even got health and safety inspectors in Australia to go and chase up and go and do visits on tool manufacturers. Generally, what we tend to find is that if you chase them up, they will put the information up there or put vibration data up there.
Mm-hmm. Perfect. Thank you. Another question we've had is there any plan to update the recommended initial vibration values published by the HSE in the near future?
Do you mean, I'm guessing you mean not the action values, but the tool data values? Is that what they mean?
I believe so. Recommended initial vibration value. I think yes, he said yes.
the tools, yeah. So we want to try and keep it up to date as much as we possibly can. That's very dependent on how many scientists we have at HSE's science division and how many tools we can get measurements of. I am personally still keen on the idea of trying to get some sort of system running where people who have got credibly lower vibrating tools or credibly more vibration efficient tools can, tell industry that they are good providers and get that stuff badged up. So that is something that I'm hoping to look into in more detail over the next few years. But we've tried to get that off the ground in the past, and the complexity of it is quite difficult. But we do intend to update the vibration tables as we go through and we gather more data.
Perfect. Thank you. Oh, we've been flooded with questions now. Goodness. I'll start with a fairly straightforward one. Can you provide examples of IIT? So what specifically should be covered for that?
So if somebody is if you're above the action value, then the expectation is that you give information, instruction, and training to your employees. The fundamental expectations for that are that you would help them understand that there's a vibration risk, that they would understand what the level of risk is or what their exposure is likely to be before they start doing the job. They should also understand what controls that you've put in place and how they would work. So if they're having to use a particular tool to reduce vibration or work in a particular way or use a particular consumable or change that consumable, then they would understand that. There's also an expectation in IIT that they're aware of what hand-arm vibration syndrome and carpal tunnel syndrome is. I think you could probably argue now that Dupuytren's contractures should be included in that because that is also listed as something that could make you ill from using vibrating tools, or something you could get from using vibrating tools. And also they should be able to understand and identify when these issues are coming on. So if they can spot the symptoms of hand-arm vibration syndrome in order to report it if it's in between the health surveillance periods.
Perfect. Thank you very much. We're getting a bit flooded here. I hope you have good stamina to get through some of these. Could you give any more information about the reliability of manufacturers' data? So,
yeah, okay. So, I mean, I think we talked here about what you should be expecting and what you can ask for. A lot of the manufacturer's data is lab based, and in some instances, in a lot of instances, that is what they're legally required to produce. If you're looking for more information on that, I don't have the number here with me, but if Sue Hewitt's listening, she might be able to drag the number out. But there is a report on our web page which explains or looks at a range of different power tools and the test methodology to see which ones are more accurate and which ones are less accurate. So, for instance, some standardized test methods tend to favour the power tool, and so they get a lower number. Some standardized laboratory test methods tend to disfavour the power tool, and you end up with a much higher number. As I say, the thing that we would expect you to do is if you're looking at the manufacturer's data, is make sure you've got the right bit of data. Usually you find the best place to find that is in the manual. That's probably where the information is the most reasonable, the most information you'll get. You'll get information on the key value there as well, more so than possibly on the web pages. And also to then go and check that against other data sources. So we've got our data source, but there are online tool data sources as well. I know, for example, that the Higher Association Europe has been working on quite a sizable bank of data that covers everything from noise and dust and vibration that you can access. That most of the tool manufacturers have signed up to trying to create that.
That's very interesting. If you could pop a link in for us, that's I'm sure we'd all love to check that out. So I kind of have a related question to that. I'm sorry I'm being selfish, you guys, and putting in my own question, but there are databases online to find tool manufacturers, tool vibration data. As long as that was collected by the Cube method, is that an okay database? Like, I mean,
well, I mean, it's not. It depends on what they've collected, because some of them might be using older measurements from a single axis accelerometer. It depends what it is, but they'll have stated which standard it's against, and so that will be the thing that will help you understand whether or not it's something that you can use. Generally, they won't say whether it's been. Well, they may not say whether it's been measured in use or whether it's been measured in a standardized test rig, but a lot of them will give you that information. But okay. the thing that will be the giveaway will be which ISO standard they've been tested to.
So as long as it's to that correct standard, then you could use that database.
Yeah, like so, grinder manufacturers will tend to state the vibration levels against the standardized lab test, which the number of which I can't remember off the top of my head. So you may find that that's slightly different, but they will all be using equipment which is compliant with the international standard.
Perfect.
A lot of them as well will also produce vibration data where they'll say this is vibration data, but you can't, and it can be used for risk assessment or it can't be used for risk assessment. So some of them will tell you that.
Lovely. Thank you very much. Another question we have here, where can you find K values to adjust manufacturers' lab-based data?
So it should be stated with the vibration data. So if the manufacturer stated the magnitude of the power tool, then that should be next to it. As I say, you may not necessarily find it on their website. Some of them do, some of them don't. What you do tend to find is that if you have a look at the user manual, which I have to say, in my experience, most manufacturers, if you're on their website and looking at their power tools, you can download their user manual quite readily, and that's usually where you'll find it. The easiest thing is if you download them as PDFs, I just search for M/S, and that'll take you straight down to wherever it happens to be buried in the user manual.
Perfect, thank you. If trigger times are being measured in combination with appropriate rotations and tool breaks, what do the HSE expect the duty holder to do next from a continuous improvement perspective?
Sorry, could you read that out again? I missed the first
bit. So if my audio. Sorry. If trigger times are being measured in combination with appropriate rotations and tool breaks, what do the HSE expect the duty holder to do next from a continuous improvement perspective?
Well, I mean, again, I said before, we're not looking for constant and continual monitoring. That's not something that we would expect to see. As with everything in health and safety, the expectation is that you understand the risk before you put somebody out there. You do the risk assessment on working on the roof before you go up on the roof, and that's fundamentally the same thing that we look for here. So we're looking for a credible estimate of exposure. And once you've got that and you understand whether the regulations apply to you, you then focus in on what you're going to do to control that risk. So we're looking for duty holders to have a good understanding of where they are in terms of exposure, and they spend as much of their time as they think reasonable to try and control the risks that they've got. So as I said, the first port of call for them, we have a look at that operational guidance thing, see if their industry's mentioned in it, and look for controls. If there's nothing in that, or there's limited information in that, the next step down for a duty holder would be to go to their own trade association and look for controls there. So if you work for the Drilling and Sawn Association, or you're a member of that, you've got a really good document on vibration control. If you're involved with the British Constructional Steel Association, they've got an entire document on noise and vibration control. These things are out there. We've got a load of case studies on our website. We've still got a downloadable PDF document on vibration control on our website that we would expect people to have a look at and see if there's anything that they could use there. After that, we're talking about tool maintenance. We're talking about making sure that you're training people to use equipment correctly, because that can have a significant impact on how they're controlling their exposure. We're also looking at whether or not you're replacing the consumables regularly, so good sharp consumables on a power tool can reduce vibration. You can sometimes buy things to add, so grinders, if you use certain types of backing discs, that can reduce vibration exposure. So those are the sorts of things we're looking for. The job rotation is kind of low down in the control process, but it is a credible way of controlling. And I think I kind of touched on that with people that are doing dry rock repair, that they will split the work maybe over 2 days to avoid that type of thing. And then the last thing that we would probably be looking for is that you're making sure people aren't getting cold and wet when they're using stuff.
Lovely. Thank you. Are you able to recommend references for understanding the risk health effects from exposure that's irregular but intensive for short periods of time? So, for example, an assessment for firefighters undertaking rescue activities for 2 days, 15 days at a time.
So, with that specific issue with emergency work, there actually is an allowance in the regulations for people that think that they're in that position, that you can ask for a kind of a bit of a dispensation there. We've seen this sort of issue recently with all the trees that came down with the bad weather. Fundamentally, we're not going to stop people from doing emergency work in order to get it done, but we do expect there to be some kind of assessment of the risk. The types of things that we've seen being done in the past, if you take utility repair as an example, so you have people out sort of digging up utilities, and then they might have to be on call at night because there's a sudden burst pipe or an electrical line goes down and they have to go out and dig up the road. What we tend to suggest in those instances is, and what we've seen people doing in those instances is to limit the person's exposure during their typical working hour, and then when they're out on the emergency call, the exposures are, the exposures aren't as significant as they would have been. For fire teams, that type of work, a lot of the stuff that they're using is hydraulic, and so we're not seeing as much vibration from the types of tools that they're using. And usually the length of time that they're using it for cutting people out of vehicles is relatively small. So the emergency work that we tend to see that's most likely to have an issue with is tree removal, or cutting people out of trees, or trying to remove trees from roads. I don't know if that's particularly helpful what I've said there, but
no, perfect. Thank you. Next question. So there's no legislative requirement to measure the tools. However, if a site has an older tool set, is it expected then that it'd be better practice in that case to measure the tool's vibration magnitude?
So I mean, if you think there's a particular issue with the tool and it's getting so old that the vibration levels are going up, it's maybe time to replace it. One of the expectations on your control activities is the maintenance of the power tools. We are fully aware that some power tools are consumables. I don't think anybody out there is maintaining and keeping a basic 125mm grinder in good order. I think what they do is they just buy a new one when it's done. So, but there are older power tools that we would expect to be maintained. So if the thing's going out of quality and the vibration levels are going up, you probably should be looking at getting a new one, because it's unlikely to do the job as well as it used to. If you're kind of continue using something and it's still working as well as it always did, then we will be looking at what the maintenance schedule is of that and seeing if you're matching that maintenance schedule. Because we look for maintenance on power tools, and fundamentally what we can ask for is that you're complying with the manufacturer's advice on the maintenance for it.
Perfect. Thank you. I kind of have a connecting question to that. I heard that the vibration magnitude, it can deviate differently depending on the tool. So for example, like rivet guns might not have a big deviation if it's poorly maintained versus brand new. This is different to things like angle grinders, which can have big standard deviations. Is that correct, what I'm saying there with the deviations, and where could we find that information to know how to better select?
I mean, well, again, this comes back, we don't ask for measurements, and one of the reasons why I think the decision was made not to ask for measurements was because of the variation that you can get just from measuring the same tool used by the same person with the same equipment and the same consultant. So there is variation in all of this, and yes, there is variation in tool types, and there is even variation in the same tool from the same manufacturer. So they may have made an alteration to the tooling process for one of the components, and that might change it, or they may have changed a component for a cheaper one or a better one in the manufacturing process, and that can alter the vibration level. So there is a lot of opportunity for variation by the person doing the measurement, by the way you've connected the equipment to the tool, by the type of tool you're using, by the age, by the condition of the consumable, by the way that the person's using it, by whatever it is that they're using it on. So there's lots of options here for variability in the measurement. And that's one of the reasons why we say, look, we're not asking people for measurement data, and we're not looking for pinpoint accuracy when it comes to understanding exposures. What we're looking for is that you understand, am I likely to be above the action value? Am I likely to be above the limit value? If your answer to the first question is yes, then you apply the regulations.
Perfect. Okay, that makes sense. Thank you. Carrying on, how be updated even if the duty holder thinks there's been no change? The wording was every 2 years, but that's been changed. Is that correct?
I missed the start of that. It went mute.
Oh, I'm so sorry. My darn audio is terrible. I'm sorry. How often should the risk assessment be updated, even if the duty holder thinks there's been no changes?
Right. The expectation on updating the risk assessment is if you have changed what you do, or there's been a substantial difference to something that you're doing in the work. That it isn't a case that it should be done every 2 years or every 3 years or every 6 months. It should, if your work activity changes or you're doing something different that you think is going to actually alter the vibration exposure, then you would redo the risk assessment. So it's not a case that it's done on an annual basis. It's done when you think there's an alteration to the risk.
Mm-hmm. Okay, perfect. Thank you. Next question. I think you may have answered this pretty much already, but have there been any experiments, testing done with a tool as new and then several months older with different consumables, different stages of its life? Where can that data be found?
Well, I don't think we've got that data on our web pages. We do have a significant data set that we base our values on, and the tools that we've done the measurements on have been from a variety of places. So some of it is brand new tooling, some of it is tooling that has been used on site by people, and so will be older. I don't think we have ever issued anything that specifically says this is where you would see the decline in performance of these particular tool sets, because fundamentally what we discovered is that the variability is large or relatively large, regardless of whether it's old, new, you know.
Perfect. Thank you very much. I'm just whizzing through to see some of these questions we covered a little bit already, but oh, excuse me. Oh, here we go. This is a good one. Okay. Could you please clarify what, in your experience, is the difference between the two compliant measurement options? So there's the cube firmly attached, and then palm measurements using a handheld adapter. In what case would a handheld adapter be more appropriate to measure vibration?
So the handheld adapter would be more appropriate to use if it is not possible for you to use the fixed in place method. So if it's not feasible for you to do that, that's the point at which we would expect to see the handheld method being used. But we know that it does get used a lot, and we know that there's different ways of using that, but the methodology that you're looking for when you're using the held in place one is about the type of tool. So certain tools, you may not be holding them in the correct way that a handheld adapter would be suitable. Sometimes we've seen handheld adapters used because it's the workpiece that has to be held in order to get the vibration measurement, and so you don't want to be, drilling or clamping things onto something that's then going to become a finished product. But it's the expectation is, if you can fix the mounting system, the typical vibration measurement system to the tool, you would use that one. In instances where you can't, you would go for the handheld system.
Okay, well, one thing that comes to mind, maybe like a pedestal grinder, where the material you're holding against the grinder, you can't really put a cube on that, something like that.
Yeah, that sort of thing. But some of the handheld systems as well are shaped to fit onto tool handles as well. So it may be the case that you're using a tool that doesn't have a natural sort of pistol grip on it or something like that, or the way that it's held is significantly different, that you're not getting good contact. So the expectation is that if you are going to use a handheld adapter, that you're checking that you're getting good contact with the handheld adapter and the piece of equipment or the tool that you're using.
Mm-hmm. Cool. Thank you. Next one. Temperature change affects halves. Is there a need to review the risk assessment more frequently, like winter months, for example?
Well, again, it's when you think the risk has changed. I don't think I've ever seen anybody reevaluate the risk assessment because they're going to be working outside more often. If you think that that's the worst case scenario, that's probably when you should have your risk assessment based on that. But the cold weather thing is difficult to quantify exactly what the specific level of additional risk is from that. We just know that working in the cold isn't good, and that you should be trying to either avoid it, and obviously that isn't possible in every case. And so if people are working in the cold, you make sure that you're providing them with warm clothes, gloves, and maybe even a change of clothes if they're going to be working in the wet. To me, it would be more important that you're providing those types of things and could demonstrate that they were keeping warm and could keep warm than being able to show me that you've got a risk assessment that says this is what we think the risk is in the winter and this is what we think it is in the summer.
Mm-hmm. Okay, perfect. Thank you. I kind of have a connecting to that as well. So, I mean, what we've learned, the EAV, the 2.5, it can be a bit finger in air in a way, because there's such a drastic difference in vulnerability to the individual. So could we ever advise, I know this is, the answer is already going to be no, but let's say if somebody is who is not especially susceptible to halves, who's working in a warm environment, has the best ergonomics, perhaps 2.5 isn't the best number for them, perhaps it's 2. And then the opposite. So maybe it's cold, it's poor ergonomics. Well, maybe you should actually go for 3. You see what I'm saying here? Can we adjust within reason? Or
the 2.5 isn't a safe level. So that is the level at which the regulations are set. There is still a risk for people that are exposed to vibrations even down to 1 meter a second, 8. So the 2.5 is not below this, and you're absolutely safe. It's just that below that, the regulations are not necessarily enforced. But certainly if somebody was, let's say you have somebody who's been diagnosed with hand-arm vibration syndrome at potentially a later stage, and you were limiting their exposure, you may be limiting it to well below 2.5, but you would still apply all the regulations to them because of their diagnosis of ill health.
Okay. Okay. Yeah. No, it depends on the situation. Okay. No, that's fair enough. Thank you. Next one here. Why are vibration magnitudes obtained in a lab condition for pneumatic breakers, why are those drastically lower than those measured in the field during real use?
So I did a talk about this a while back. So they use a thing called a Dynaload, which is essentially a tube full of metal ball bearings, although very small ones. So that the way that it's tested, for a lot of the ISO standards, and this is across the board, it's not just a noise and vibration issue, the main thing that you're looking for is reproducibility and repeatability. And so in order to be able to establish a baseline level to say this power tool is probably less vibration than this other power tool, they want to have a test methodology that they can reproduce and repeat anywhere in the world. And so that would be the reason why for some power tools, that standardized method tends to make the power tool produce lower vibration. So nut runners, for example, the standardized method for that is that they're put into a jig and they're run at the extreme where the thing's sort of clicking over. Now, anybody who uses a nut runner would never do that. The minute it started to click over, they knew that they were the limit of the torque of the tool and they would stop driving the bolt in. But the way that one's tested, it overestimates, or has the potential rather to overestimate the vibration exposure. So that's the reason is that the main aim for the standard is repeatability and reproducibility, so that you've got a baseline upon which to assess the quality or the differences between different manufacturers and different tools.
Lovely, thank you. And a connecting question to that was, are there any steps to tackle this issue? Because, for example, construction workers are often overexposed due to reliance on the manufacturer's data.
So they've still got a requirement to state what any kind of residual risk is. I think that's probably a bit more esoteric and difficult to get an understanding on. But that's why for a lot of the power tools that you're looking at, we would suggest you start off by looking at the data that we've got. We've tried our best to get as wide a selection of common tools on that. There's a couple of obvious admissions that should be on there, and we are kind of working towards getting more data on different things to add to it. But again, there's nothing to stop you asking the manufacturer for in-use data and seeing can we have that.
Lovely, thank you. You guys are asking really techie questions here. So we have another K factor question. Is there a rule of thumb for adding a K factor? Is it tool material dependent? How can someone confidently add a K factor to their group of measurements?
Well, the K factor will come with the tool. It's usually based on a lab measurement. So you've got to start off from the position of this is a laboratory measurement, and it may not necessarily be, or it's got the potential to be a laboratory measurement, and it may not necessarily be the tool in use. But effectively, if the K value is 1.5, you would add that to what they are stating as the vibration magnitude. So it's as simple as that. I know we used to have a thing, or there used to be something on our guidance where we were talking about adding a percentage. I won't say what percentage, because I know the minute I say it, people will start adding it. But that's not on our guidance anymore.
Okay, thank you. I like this question here. From your own experience, can you give us like a range of exposure controls that you saw were least satisfactory to most effective? Like what works well out there?
I'll tell you what's a really good vibration control is not to do the thing that you're doing. So the best one that I'd seen in the past was, again, I'm sure people will be bored if I tell them the same stories, but I came across people that were using small handheld grinders to number up steel panels, and the solution to that was to use an indelible marker. That's a really simple solution that doesn't cost £1.25 for an indelible marker, instead of having people have surveillance and paying for power tool maintenance and that type of stuff. So, elimination is what the sort of key aim that you're looking for. And sometimes the solution to it is something that's really, really obvious. Again, came across a company that made metal signs, and they were buying highly polished steel plate and removing a plastic coating which was protecting it, and then scuffing it up with a handheld grinder in order to then allow you to get a key for the paint that they were using. And they found out from speaking to the manufacturer of the paint, they didn't need to do that anymore. They could have stopped doing that 20 years ago. So the elimination is the best option by far. And I think one of the things we've noticed with duty holders is that over the course of the last sort of 20 years since these regulations came into force, they have naturally changed the way that they work. Nothing to do with vibration, nothing to do with noise control or anything else. It's just technology's moved on, and so have they. And they forget that they no longer do the things that they used to do. And I think it's always worthwhile to have a think about how you used to do things and how you do them now, and tell us about that if we turn up. So, went into a welding metal welding fabricator where they making portal frame equipment, and they were in the process of purchasing a lot of robotic welding equipment, and they were finding that the amount of grinding that they had to do after that was significantly lower as well. But they'd never considered that as a vibration control or a health risk control for welding fume. They just bought these things because they knew that they could manufacture more stuff more quickly by buying this piece of equipment. But yeah, elimination's the best thing. But yeah.
So it's good to think outside the box, isn't it? Find these clever solutions. I don't see any more specific questions, but I'm going to ask one or two of my own, if that's okay. And you guys, please, we have Chris for 7 more minutes, so do drop in any extra questions here. One thing I absolutely loved the part of your presentation, which was talking about reporting expectations. So what should us, as for example, hygienists, be including in a HAVS report? And some time ago, you guys produced the noise at work consultants guide. The thing I've talked about is the purchaser's expectations with the green and the orange and I'm sure you guys know what I'm talking about as well. That for HAV reports would be wonderful. Is that planned? Do you think we might get some equivalent?
I don't think we have anything like that planned at the moment. Sue Hewitt's been working quite sort of heavily on this, and she's been speaking to vibration consultants. So the first sort of step is to have if you're a duty holder, this is what you should expect from a consultant. That's the first thing that we hope to get done, and we've had a lot of help from the vibration sort of community in producing that. And the other thing that was also produced as a process of that, or is kind of getting near finalisation, is a sort of, well, here's a starter for 10 appendix that we would say, pretty much every consultant could put this into their report, and it might be helpful for the duty holder to make sure that that's there as a kind of, here's some basic stuff that you can do to control, and here's some basic expectations for the duty holder to prepare for when the consultant arrives, so that if you turn up to do vibration measurements or even just a vibration assessment, that they're ready for you, that they've got all the information waiting for you, and it's a successful process. So that's what's in train. But again, I don't want to say when that's going to happen, because I spent a lot of time apologising to a lot of people about how long it took to get the vibration measurement and monitoring stuff up on the website, and I apologise again for that to them. I would love them.
No, wonderful. That's great. The reason why this is a little bee in my bonnet, this topic, is I've seen a number of poor reports from other consultants doing Hanar vibration, and I think I already know the answer that you'll give me to this question, but I'll ask it anyways. It's just taking the magnitude and giving that data to the client enough, and then just giving them the link to the HSE's calculator to input their own trigger times. Because Yeah.
I mean, it depends. I mean, fundamentally, it depends what they've paid for you to do. If a company has paid you to come in and do vibration measurements because they wanted the data and they'll figure it out themselves, there's no issue with that. I don't have an issue with that, as long as it's clear that that's what they're paying for. The problems arise when they were expecting a hell of a lot more. So yeah, if someone says, and I've spent the last sort of half hour saying we don't expect measurements to be done, and you only do it on instances where you absolutely have to. So in theory, that shouldn't be that unusual that a company would phone up and say, we've got 2 or 3 power tools we just can't get data on. Can you come in and get the measurements and we'll figure it out? So I don't have an issue with that. And as long as that's what was agreed, the problem is when that's all that's been done, but the expectation and the duty holder is you're the person that's dealing with our issues. On a slightly different note, but certainly around consultancy reports, and I will be talking about this later on in the year, we are, and HSE will be, as a matter of course, when they're out asking about noise, we will be collecting noise at work reports. We had a small trial of it on the woodworking visits that we did last year. We're now going to be doing that on pretty much every visit that we do where we find a noise issue, where we find noise is a controlled issue on a site. And the intention with those reports will be to send them off to Science Division and do data scraping on them, partly to see what the current sort of noise levels are, where the current industry is in terms of control, but also to evaluate the quality of the reports and see who the biggest sort of providers are for workplace noise reports from the consultancy side. And if we find poor reports and consistently poor reports, we are then going to go out and speak to those consultant companies.
Right. Well, everybody watch out for noise then. Yeah, it's going to come under some heat. Awesome. Yeah, no, wonderful. Any other questions? We have a few more minutes left. Go on and plunk them in there. You guys are very welcome to raise your hand and unmute if you want to ask, yourself. Saves my voice reading. Yeah, go ahead, Peter. Oh, did you have your hand?
Yeah. I did. Can I go?
Yeah, you go for it. Mm-hmm.
Thanks. So, Chris, sorry, I came a bit late to the party and I missed the first portion of your presentation. I'd like to know, is the presentation available and the recording, is that going to be made available?
Yeah, so I believe it's going up on the BOHS YouTube channel, and also I'm going to send through the PDF versions of the slides to BOHS.
Perfect, thanks, Chris. And then, okay, the technical question. There's methodology currently available to take a measurement on the body or on the wrist itself. To in essence then extrapolate that data as though you would, well, there's certain algorithms and calculations performed to have a look, almost as if I suppose you would be taking the measurement on the tool itself. So there's some sort of a correlation data or calculations. What are your thoughts on that? And taking hand-arm vibration measurement is traditionally not that easy to do because you've got to put a clamp onto the machine, or you've got to put some sort of a palm adapter onto between the person's hand and the machine, and if they're wearing gloves, it's difficult. So this type of methodology makes things a lot easier. What are your thoughts on that and advanced technology in terms of hand-arm vibration assessment?
So I mean, I keep coming back to the fact that the regulations were kind of written at a time when there wasn't a lot of people out there doing vibration measurements or monitoring, and they still have this baseline expectation that you can effectively have an understanding of what people's exposure is without having to do measurements. And that would be our kind of starting point for any organisation is, we're looking for a credible estimate of risk, and we're looking for you to concentrate your efforts on control, information instruction training and health surveillance. So it's not something, we don't ask for measurements, we don't ask for monitoring. And so we're unlikely to ask for a different measurement methodology as something that we would expect to see as a regulator. So coming on to your point, which is, well, what do I think about these types of things? Well, technology moves on, and my understanding with these types of systems is that they are in the process, or they're trying to go through the process of getting a standard written for it. And from HSE's perspective, our position is, this is what the guidance document says, this is what the regulations say, and in both instances we reference an international standard if you want to do measurements. If that international standard gets updated to include those types of systems, then I really have no concern about it. If everybody in the world agrees that that's a way of doing hand-arm vibration measurement, then it would be something that we would accept. So it's about that. You know, the simplest thing for us is we work to a set of regulations. Those regulations tend to reference international standards when it comes to measurement, and we rely on the international standards community to develop and define what is the way of doing measurements. So the stuff that I've talked about today is, you know, frankly, stuff that has come from international standards to show you what they say.
Yeah, thanks. And then, so if I'm understanding what you've said correctly, it's ultimately about quantifying risk in such a way that you can justify or stand by your conclusions in terms of the numbers, and use, let's say, innovative technologies to be able to quantify risk, obviously taking cognizance of the normatives that are currently available.
Yeah. The key thing for us is, you know, we are a slow-moving, organism. We are not an organism. HSE is not an institution that moves quickly, and we are at the end of the cutting edge. I know we've got a science division, they might be upset that I've said that, but fundamentally the regulatory position is created because there has been a general consensus on what good should look like, and then a regulation is brought in. If everybody could agree on an issue, there would be no need to regulate on that issue. And fundamentally, there has to be an agreement reached on how measurement is done. And for us, the way that agreement has been reached is through those international standards. So if the international standards agree that there's other ways of doing it, and they put that into the relevant standards that we reference, then it would be something that we would accept. But as things stand at the moment, the methodologies that we've explained so far are the ones that are generally accepted for doing vibration measurements to gather data that can be used in a workplace risk assessment. Whether that changes, I don't know. And to be honest with you, that's not something that I get involved in. I'm sort of frontline and regulatory, trying to enforce regulations that have kind of been set up for sort of decades.
Lovely. Thanks, you guys. We've gone a little over time, and I dare not eat in too much of your day, Chris. So just to say thank you so much, everybody, for attending. Excellent presentation. I think we had a lot of questions answered today. So, Chris, you could have your own talk show, honestly. People would just sit, they would just line up and ask you questions all day. That could be your full-time job. So, but no, thanks so much, everybody. I'm sure you wouldn't mind being contacted if anybody had any other questions.
If anybody wants to find me on LinkedIn, you can. I'm happy to link with anybody there.
Perfect. Oh, lovely. Okay. See you next time, everybody. Thanks for coming. Nice. And you can watch again on YouTube if you've really enjoyed.
Thanks. Bye.
Bye, everybody. Thank you. Bye.